In this tutorial, we are going to get into trigonometric or trig ratios. The relationship between angles and sides of a right triangle are expressed in terms of trig ratios. For instance, it could be sine of 30 degrees or sine 2 pi over 3, and so on. Now, let's talk about classification of angles. All angles can be broken down into the following categories. The first one, if the angle is less than 90 degrees, then it's called the acute angle. The next one, if the angle is lying between 90 degrees and 180, then it's called obtuse. Next one, a straight line which is 180 degrees is called the straight angle, so actually the name implies itself. Reflex angle which is greater than 180 degrees. The next one is a right angle which is exactly 90 degrees. And finally the last one is a full rotation which equals 360 degrees. Now let's jump into elements of a right triangle. Say we have a right triangle which has a right angle C, which is denoted by a little corner. Also, we are given the angle theta, which is not a right angle. What's important to know what the sides are in relation to theta. What I mean by this is the longest side of the triangle, which is C or AB, is called the hypotenuse, or it's the side which is opposite the right angle from that point of view. Now, the side which is next to angle theta, but it's not the hypotenuse. It's called the adjacent, so again, it's the next to angle theta. It's A or BC. And finally, the side which is directly across from theta or furthest from the theta is called the opposite side, so it's gonna be B or AC. Now, work out mentally. Choose different angles of triangle ABC, and according to this angle, name all parts of triangle ABC. So, let angle theta be angle B. So, the longest side, which is AB, is gonna be the hypotenuse. Next to the theta is the adjacent, so BC is going to be adjacent. And directly across from angle theta, the side AC is the opposite side. Now, let's dive into definitions of trig functions. Say we are given a right triangle, angle theta is labeled. Also, the small letters A, B, and C are used to represent the sides of the triangle. Also, we are given, obviously, a right angle, which is C, denoted by a little corner. So, normally, the lowercase letter c means the side which is across the angle C, the capital C. So, the opposite side B is denoted by lowercase b, which is across, directly across from the big B. And finally, lowercase c means the hypotenuse, which side is directly across from capital C. Now, by definition, sine of angle theta is the opposite side over hypotenuse, or B over C. Cosine of theta, by definition, is the adjacent side over hypotenuse, or A over C. And tangent is just the ratio sine of theta over cosine of theta, or opposite over adjacent, or B over A. Also, let's introduce reciprocal functions. Cotangents of theta is going to be 1 over tangent, the reciprocal of tangent. Secant of theta is going to be reciprocal of cosine, 1 over cosine of theta. And cosecant theta, by definition, is 1 over sine of theta. Alright, mnemonic trick is meant to memorize the definitions of these 6 trig functions. SOHCAHTOR, or as people quickly say, SOHCAHTOR. So S stands for the sine, O stands for opposite. Now H means hypotenuse, C stands for cosine, and T stands for the tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. So it's really worth to remember. Now, as a quick recap, Pythagorean theorem states that the square of the hypotenuse of a right angle triangle is equal to the sum of square of the other two sides, or sometimes they are called legs of the triangle. In other words, algebraically, c squared equals a squared plus b squared, where c is the hypotenuse and a and b are sides or legs of the given right triangle. Now we're going to solve right triangles, as it says. Say we are given the right triangle ABC, angle C is a right angle, 90 degrees. And we need to find sine of theta, cosine of theta, and tangent of theta, and also their partners, cotangent, secant, and cosecant. The angle theta is also given on the right triangle. Also, we are given two sides, AC, which is 8, and BC, which is 6. First of all, let's label the sides of the triangle in regard to theta. So the longest side, which is AB, we're gonna call also C. It's the side which is directly across from the right angle C. Is gonna be the hypotenuse. Now, from angle A, so the side which is 6 is gonna be A, and the side which is 8 is gonna be B, so it's directly across the big B, capital B. So the side A is gonna be the adjacent side, it's the next to theta, and side B is the opposite side, it's directly across angle B. Okay, now, since we don't know the hypotenuse side, but we need to know in order to calculate trig functions. First of all, let's find this side by using the Pythagorean, or Pythag, as school kids say, theorem. So, according to Pythag theorem, c squared equals a squared plus b squared. So, in order to find c, we need to take the positive value of square root of this sum. So we know a and b, so let's plug in these values and figure out c. So a is 6 and b is 8, so it's gonna be a square root of 6 square, which is 36, plus 8 squares, which is 64. So it's gonna be 100 underneath the root symbol, and square root of 100 is just 10. So the hypotenuse, the longest side, is gonna be 10, and we can label on a right triangle. Now, we know everything in order to find trig ratios. So let's proceed with sine. Remember the mnemonic device, the mnemonic trick. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's implement this. Sine of theta equals opposite over hypotenuse. Alright, as a quick side note, when we deal with trig ratios, for instance sine, make sure you put angle theta or whatever angle you are given next to the sine. So sine of theta, sine of A. You don't want to write sine equals, which makes no sense. There is no meaning in this, since many people forget to write the angle. Now, let's get back to sine of theta. All we want to do is just plug in the values. So opposite is 8 and hypotenuse is 10. So it's gonna be 8 over 10. And we want to reduce this fraction. Always make sure we get it down in the simplest form possible. So 8 and 10, they are divisible by 2. So that would leave you with 4 over 5. Now, let's do cosine. So we're going to take the second part of this mnemonic device. So it's adjacent over hypotenuse. Now, your adjacent side 6, hypotenuse is 10. So it reduces to, again, we can simply cancel off 2 from top and bottom, and it reduces to 3/5. And finally, for tangent, we will get, so tangent of theta, it's opposite again over adjacent side, and we are going to grab these values. So the opposite side 8 over adjacent is 6. So it simplifies to 4/3. That's your tangent. We are not done. We need to come up with the partners, the reciprocal functions. It's going to be just piece of cake. So cosecant of theta, by definition, it's 1 over sine, the reciprocal of sine. So all we want to do is just flip this fraction for sine. So sine 4/5. So cosecant, it's gonna be the flipped version, 5/4. Similarly, for secant of theta, we get 1 over cosine by definition, and all you need to do is just flip this 3/5 for cosine. So the flipped version is gonna be 5/3. Done. And finally, for cotangent, we wanna grab the tangent value and switch top and bottom. So it's gonna be 3/4. That's the value for cotangent. Perfect.